Hi, I'm Carl Hild. I'm with the University of Alaska Anchorage, and here to talk a little bit about the movement of contaminants and how they move from the big environment up until people and into the diet. But I wanted to give a little history first. I don't know how many of you are familiar with this particular photograph. This picture was taken from space in 1969. It was one of the first times where the people of the Earth got to see their own home. And so here was an opportunity to realize that the Earth is just a very small blue marble floating in space. And everything that we know, the life that exists in the world is on a very thin film. The comparison has been made that if you look at an apple and the thickness of the skin of the apple, that's like the entire biosphere of the Earth. The thickness of that skin represents where all life is, from the deepest places in the ocean to the highest places in the atmosphere. So that very thin veneer is where life exists. Now within that sphere, over the past 50, 100 years, people have contributed something that is now known as POPs, persistent organic pollutants. These POPs have been made a number of different ways, but some of them were designer engineered chemicals, so that in order to make chemicals that would sustain themselves for a long period of time, they wouldn't break down under high heat, under electrical current, under extreme temperatures of all different kinds, that some of these chemicals were designed, but when they got released into the environment, what was found out was the fact that they don't break down. Well, they had been designed not to break down. Subsequently, what they found was that these chemicals will move throughout the atmosphere. And so in a globe, what happens is some of these chemicals were used in spraying for, let's say, agricultural pesticides or herbicides throughout the growing regions of the globe. So this is more towards the equator. Well, as they were sprayed, these chemicals were also volatile, which means when they were heated a little bit, they would go up into the air. So they would volatilize around the equator where there's plenty of warm sunshine, and then they would cool off and precipitate down. Then when the sun got warm again, let's say in the summertime, they would revolatilize and move again to the north. And they would keep moving until they would finally precipitate down in an area where it was too cold for the chemicals to revolatilize, so they stayed there. And that usually happened when they got to the Arctic. Now what happens over the years system is the fact that the Earth has a tilt to it. And so in the summertime, the pole, the North Pole, is facing the sun. And so you get this warming trend. Then as you come to wintertime, the North Pole is facing away. Well, the colder temperatures, the fact that this part, the polar Arctic, does not get the sunshine, it gets dark, what happens is all those contaminants that have been moving up to the north settle in. Now the air is very cold and very dense. And so that cold, dense air will actually hold more pollution than cleaner, warmer air that would allow it to fall out. So that dense air holds this, and some of the pilots who were flying across the pole said they saw this thing called the Arctic haze. They saw this layer of dark air across the pole. Well, they've now determined that there's an area around the North Pole that forms what's called as the Arctic front. So in the wintertime, all this dense, polluted air holds in the dark environment in the cold of the wintertime, and it doesn't move. It just stays there and accumulates, gets more input from the south, but it doesn't break up, it just stays there. Then, as springtime comes around and the sun starts hitting onto the north before it gets to summertime, that warming trend breaks that Arctic haze out, and the pollution precipitates out along the edge of the Arctic haze. Well, as Alaska is way up here in the Arctic, the contaminants start dropping out and they fall into the ocean, they fall into the snow in the springtime, just when the biological activity begins. So there's this opportunity for contaminants that have been moving from around the globe, settle into the Arctic, maybe reside there for 6 months, and then in the springtime, they all precipitate out at the time when the sun is coming up higher on the horizon and you get more biological activity. So these contaminants that exist in the Arctic then become biologically available for any species that may pick them up. The next piece that we're going to talk about is the issues of bioaccumulation and biomagnification. So bioaccumulation is as something lives, it needs energy. So it's constantly eating, drinking, taking in energy, And at the same time, because these pollutants have gotten throughout the entire environment, they also pick up some of those contaminants. On this particular chart, the bioaccumulation is shown in fish at 6 months, 1 year, 3 years, and 6 years. The white spots indicate the contaminants, and that over time, as the fish matures and eats more, that it then ends up accumulating more of these particular contaminants. Now, in bioaccumulation, the contaminants come into the body, and some of them will pass out. So let's say you consume some cadmium. Generally, if you consume it through your ingestion and you eat it, about 95% will go right through your body. So you only accumulate about 5% over time. So bit by bit, you get more and more cadmium accumulating in your body, but your body slowly does get rid of the bulk of it. If you inhale cadmium, it's almost the reverse, where most of it, 80–90%, stays in your lungs, and your body picks it up very readily. So it depends on how you're exposed to the particular contaminant, on how much your body will absorb. So that's one thing to keep in mind. Some products, when you get them into your system, you can excrete them. They go out, you exhale them out, they go out in your urine or your feces, but they move out of your system. Others are known as being bioaccumulative because they attach themselves to certain tissue. Now, with some of these persistent organic pollutants that I mentioned before, these are lipophilic. They attach themselves to fat. Matter of fact, they're called fat-loving, so they really do get attracted to fat. Now, when you think about this, as you have small animals that collect some of these contaminants, if a bigger animal comes along and eats them, they gather up all the contaminants that the little animals had. And so you can end up, if these are, for example, these lipophilic, fat-loving molecules, if one animal has a little bit of fat and another animal eats that fat because they need the energy, then they accumulate all the contaminants that have been locked up in the fat. And as this moves up the food chain, you see more and more of these contaminants in the fat and moving up to the next level of consumer. And so this becomes biomagnification. So I'm going to do a little demonstration here to show how both bioaccumulation and biomagnification work. So what we have here is the environment, and it has many things in it that organisms want. Sometimes they'll go through and pick things up, and that'll be their nutrients. Other times there'll be contaminants that they don't want, and sometimes they'll pick things up and then excrete them shortly thereafter. So let's say we have a little microorganism, and this little guy starts floating around and picks up some things here, but finds some other things it's not interested in and moves around and finally decides to settle down. So we'll have these guys, and this is the process of bioaccumulation, that they are now accumulating these various things from their environment. And so what we see is that some things get left alone and other things get picked up. Now let's say, in the same example, we now have some fish. And the fish go around and they're not looking for necessarily these things in the environment, but they are looking for possibly some things they can eat, but definitely looking for these little guys. And so they start accumulating and picking some other things up that they're interested in. So as the fish move around, they're picking up various items in their environment. So we have a bigger seal. And so this seal picks up that fish and can pick up the next fish. And so you can see it's beginning to bioaccumulate a number of different things and actually magnify. So let's say this seal has taken this fish over here, and we have these two seals. Now, the next level of predator would be a polar bear. And so the polar bear comes along looking for the seals and can pick up everything that was in the seal as well as everything that's in the next seal. And so the polar bear has accumulated much more of the contamination and some of the issues than any of the other animals.